Welcome to the DIY Honda Garage channel. In this presentation, we will troubleshoot the diagnostic trouble codes DTC P2237 and P2240 as they apply to the 2008 to 2012 Honda Accord. DTC P2237 indicates a high voltage issue in the rear air-fuel AF sensor circuit for Bank 1, Sensor 1, while P2240 pertains to the front AF sensor circuit for Bank 2, Sensor 1. These codes are relevant for all models of the Honda Accord, except for those designated as PZEV units, which meet California's emissions standards. Understanding how these sensors function is crucial, as they help manage the engine's air-fuel mixture for optimal performance and emissions control. In the following slides, we'll discuss error descriptions, possible causes, symptoms of the problem, and systematic troubleshooting steps. The air-fuel sensors play a pivotal role in the vehicle's emission control and overall engine efficiency. Bank 1, Sensor 1, is located on the rear exhaust manifold, while Bank 2, Sensor 1, is positioned at the front manifold. These sensors are responsible for monitoring the oxygen content in the exhaust gases, which assists the engine control module, ECM, in adjusting the fuel mixture. An issue indicated by DTC P2237 or P2240 often signifies high voltage in the sensor circuit, suggesting a malfunction. High voltage may result from wiring issues such as shorts or open circuits, rendering the sensor unable to provide accurate readings. Recognizing these details aids in identifying root causes during troubleshooting, especially when combined with onboard diagnostic data. Several possible causes could trigger DTC P2237 and P2240. One major concern is shorted wiring, which may lead to excessive voltage that the sensor cannot handle. Corroded or damaged connectors are another common issue that can prevent proper communication between the AF sensors and the engine control module, ECM. These failings can be due to environmental exposure, age-related wear, or improper installation. Additionally, the AF sensors themselves might be faulty, which would require replacement. Lastly, issues within the ECM, such as outdated software or internal faults, could also contribute to these error codes. Understanding these root causes aids technicians in efficiently identifying and rectifying the problems. When DTC P2237 or P2240 is triggered, several symptoms may present themselves. The most immediate indicator is the illumination of the check engine light, CEL, on the dashboard. This serves as a warning for the driver that an anomaly exists within the engine management system. Additionally, you may notice a decline in fuel economy, as incorrect air-to-fuel ratios can lead to inefficient combustion. Rough idling may occur as the engine struggles to adjust to the erroneous sensor readings. Increased emissions are also a significant concern, potentially resulting in failed emissions tests, which are critical for compliance in many regions. Recognizing these symptoms ensures that the issue is addressed promptly to maintain vehicle efficiency and compliance. The first step in troubleshooting DTC P2237 and P2240 begins with turning the ignition switch to the on-to position. This will provide power to the vehicle's systems without starting the engine. Before moving forward, it's essential to record all freeze data and any onboard snapshot that may provide critical insights into vehicle performance before the error occurred. Additionally, reviewing general troubleshooting information pertinent to these codes can help contextualize the symptoms and guide the diagnostic process. Ensure to keep a note of any abnormal behaviors that were observed prior to the error, as this data assists in identifying the root cause. In this step, Utilize the Honda Diagnostic System, HDS, to clear the diagnostic trouble code. Clearing the DTC is crucial as it resets any flags the system has set due to the detected issue. Once cleared, the system will monitor the condition anew, allowing it to check for recurring faults. The HDS should provide a detailed readout of any error codes and real-time data, giving technicians an informed starting point. After clearing, proceed to start the engine to continue the diagnostic process. Clear communication between the technician and the HDS interface is essential for accurate diagnostic interpretation. After clearing the DTC, start the engine and hold the RPM at 3000 without load. This process is crucial because it allows the engine to enter a specific operating condition where the AFAT sensors will be exercised under typical performance parameters. The goal is to hold this RPM until the radiator fan activates, indicating the engine has reached its temperature threshold. This operation ensures the vehicle's sensors are functioning properly. Following this, allow the engine to idle for 2 minutes, letting the system reach a stable operational state. Monitoring these conditions provides valuable data that could lead to identifying the core issue with the AFAT sensor circuit. Next, it is time to check for any pending or confirmed DTCs using the HDS. This diagnostic tool is designed to interface with the vehicle's onboard computer to identify any underlying issues. Upon checking, ascertain whether DTC P2237 and/or P2240 are indicated once again. If either code reappears, further troubleshooting is necessary as the sensors are likely still experiencing issues. Conversely, if no DTCs are found, the vehicle may have an intermittent failure, suggesting that the system is operating correctly at this moment. This highlights the importance of vigilant inspections, especially in checking for poor connections or loose terminals at the AF sensors or within the engine control module, ECM. In this next step, begin by turning the ignition switch to the lock 0 position. This ensures that the vehicle's electrical systems are powered down, allowing for safe service. The next action is to jump the SCS line with the HDS. SCS stands for the Service Check Socket, which enables specific diagnostic routines. This step is critical as it allows for further testing and verification of the sensors and their connections. Ensure that all tools are used directly as specified, as any improper handling could inadvertently cause damage or misinterpretation of results. Proper adherence to these procedures is essential for accurate diagnostics. Now, proceed to disconnect the air-fuel AF sensor, specifically sensor 1, using the 6P connector. The 6P connector is designed to connect the sensor's wiring to the vehicle's electrical system. It is essential to ensure that the connection is safely disengaged without damage to the wiring or connector itself. Handle these components carefully to avoid any additional complications. Proper disconnection allows for isolated testing of the AF sensor circuit and further inspection of the wiring harness. This step is foundational for ensuring the reliability of the diagnostic process, as any faults or discrepancies in the connector could lead to erroneous test results. The next step requires disconnecting the ECM-PCM connector B, which consists of 49 pins. This connector connects the engine control module, ECM, or the powertrain control module, PCM, to various sensors and actuators within the vehicle. As with previous steps, it is crucial to handle this connector with care to avoid damaging the pins or electrical contacts. Disconnecting the ECM-PCM is essential for performing the subsequent continuity checks between the AF sensor and the ECM. This operation requires meticulous attention to detail to ensure accurate results during testing and verification of circuit integrity. In this critical step, you will need to check for continuity between the terminal of the AF sensor's 6P connector, specifically terminal number 5, and the corresponding terminal in the ECM-PCM connector B, B31 and B32 for certain models. Using a multimeter, measure the resistance and determine if an uninterrupted path exists between the specified terminals. The absence of continuity in the circuit indicates a potential wiring fault or an open circuit. Conversely, if continuity is confirmed, this suggests that the wiring is intact and the issue may lie within the sensor or ECM. Maintaining clear documentation during this testing ensures organized troubleshooting. After completing all previous troubleshooting steps, it's crucial to recheck for any diagnostic trouble codes using the HDS. Verifying that both DTC P2237 and P2240 are cleared ensures that repairs have been successful. Once cleared, assess the overall system performance to determine if there have been improvements, specifically regarding fuel efficiency and engine operation. It's essential to carry out test drives to confirm that the vehicle runs smoothly without triggering any further DTCs. During this phase, pay attention to symptoms like rough idling or performance issues, as they may indicate lingering problems. A comprehensive review of these conditions solidifies the reliability of repairs conducted. Preventive maintenance is essential to ensure ongoing engine performance and emissions compliance. Regular checks of the A-factor sensors should be scheduled as part of routine vehicle servicing, especially during significant maintenance milestones or inspections. Monitoring the condition of wiring and connectors is crucial, as environmental factors like moisture and corrosion can affect their integrity over time. Keeping the connectors clean and secure also helps prevent intermittent faults from emerging later on. Additionally, updating the ECM software as necessary can ensure that the vehicle benefits from performance improvements and fixes. Adopt a proactive approach to maintenance to reduce the risk of recurring trouble codes. In conclusion, the air-fuel sensors in the Honda Accord are vital for maintaining engine efficiency and lowering emissions. Understanding the importance of these components is fundamental when addressing diagnostic trouble codes such as P2237 and P2240. Systematic troubleshooting steps not only aid in identifying the root cause of the issues, but also guide technicians toward effective repair strategies. Along with repairs, implementing preventive maintenance measures ensures the longevity of the vehicle and optimal performance. By adhering to these practices, drivers can maintain their vehicles and minimize the risk of future disruptions, thereby enhancing overall driving experience and compliance with emissions regulations. Please like and subscribe to the channel. See you next time.